So this is a scenario that we just discussed, right? Where does this come from? From determining and the meaning and calculating the what? The difference quotient, right? So as I mentioned before, this is a tiny, tiny error or change in x. Could be called error, it could be called just change in x, small. If I want to make it as small as possible, not equal to 0, I can't do that, because if I say h is 0, then I am telling you that p and q are the same point, and I can't do that. It would not be true. So h gets closer and closer to 0, which means q gets closer and closer to p. If that's the case, then we can say that the slope, or first of all, the secant line gets closer and closer to becoming the tangent line. And obviously, the slope of the secant line will get closer and closer, not equal to, but it will get closer and closer to the slope of the tangent line. So this is the concept that we have to work with right this moment. So let me write it one more time. So as P approaches, I wanted the other way around, sorry. As Q approaches P, as Q approaches the point, should I draw that picture one more time for everyone to have? Let me draw it one more time. It's just going to be very quick. So you'll have everything in one spot, and you don't have to go back. That's my page 7. So let's do it one more time. Here's the function f. Here is p. Here is x. This is f of x. Of course, this is q. This is x plus h. This is h. And of course, this is f of x plus h. We are looking at the slope of the secant line. The slope of the secant line PQ. We already know now it's f of x plus h minus f of x divided by h. But what we want to determine is the slope of the tangent at P. This is what we want to determine. Well, we can determine with algebra. I cannot determine the slope of the tangent line at P. I just can't. Why? Because we do not have an equation of a line that involves a point. We can determine the, if you want, just the slope of a line that involves one point. I can't with algebra. I need 2 points. I need 2 points to determine y2 minus y1 over x2 minus x1. But I'm still interested in determining the slope of the tangent line at P. One more time, what would the slope of the tangent line at P give us?
F of x.
The instantaneous rate of change, or velocity, or just the rate of change at that point, right? Good. So we're going to say that when h approaches 0, would you agree that the slope of the secant line PQ will approach the slope of the tangent line at P? Let me write tangent. Would you agree with that? So as Q gets closer and closer to P, so in other words, h approaches 0, or I can say Q gets closer and closer to P. Let me draw your attention to this symbol. When we say h approaches 0, we mean specifically h does not equal 0. So how do we read this? As h approaches 0, not equal to. We specifically mean h not equal to. Now, I would like to illustrate this with an example. We're going to pick a problem from your book, and I'll let you pick the problem. I prefer picking problems that are even number problems, so you can look at the odd number problems, but I don't care. You choose, or I will choose. I'll show you in a minute. So we are given several situations here. For example, I prefer something like this. So let me look at, scoop it up just a little bit. So let's look at 4. Okay, so we're given a point P, 0.5 comma 0. We are told it lies on this curve, cosine pi x. And if Q is the point, of course, what point is that? In this case, this is a point that is A comma B, and this is a point X comma f of X. Same scenario, same setup. Use a calculator to find the slope of the secant line PQ, correct to 6 decimal places, for the following values of X. And we're given something, some values. We're going to organize the information, and I'll show you how. So using the results of part A, guess the value of the slope of the tangent line to the curve X such and such. Ready for this? Would you like to do problem 4? Is it a yes?
Yeah.
Okay. I don't see enough enthusiasm about this. Just kidding, just kidding. Okay, so here's the point P. So this is problem 4 on page 86. We are given P, which is 0.5 comma 0, they say. And we are given the function y equals cosine pi x. And we're given several values. I'm going to copy them the way they give them to us. And then I'll show you how to organize all this information. So I'm just going to copy what they give. So they gave 0, they gave 0.4, 0.49, 0.499, 1, 0.6, 0.51, 0.501. We're also given point Q as being x, obviously, comma, cosine pi x. Ready? Okay, so here's my graph of function f of x or y. This is not the exact graph, none whatsoever. I'm just interested in picturing 0.5 p 0.5 comma 0. That's all I care about. Just imagine that I zoomed in on that function, and all I'm interested in is that point. Okay, obviously these are telling us something. So then this is 0.5. And where are all the other ones pictured? So 0.5, the next one will be this. So right here, as the next value is 0.501. So I took that into account. Where is I'm sorry, it's on the other side. Oops. 0.51, right here. 0.51, perfect. Okay, this was taken care of. 0.6, and then 1. So all these are in the correct order now. 0.5, 0.501, 0.51, 0.6, and 1. On the other side, where is the next in line to the left? Yes, 0.499, awesome. Then 0.49, then 0.4, and then 0. Okay. And where is Q? This is Q. This is the first Q for 0.501 cosine pi times 0.501. That's the first Q. Then the next Q, and the next Q, and the next Q, and on that side. And that's how I will be determining the slope of the secant line, right? So between this point and the first one, with this x coordinate, then it will be this line. Between Q2 and P, then I will have the slope of this line. And the same thing on the other side. The slope of this line would be the secant line, the slope, and so on and so forth. How many lines and how many slopes will I determine? Between 0.5 and 0.501, 1. Between 0.5 and this, second. Between 0.5 and this, third. Between 0.5 and 1, fourth. Between 0.5 and this. Between 0.5 and this point. Between P and Q here, and P and Q here, and P and Q here. How many? 4 on the left, 4 on the right. I have 8. What if I create a function that will enable me to just put the function in the graphing calculator and plug in what changes? X changes. I cannot plug in 0.5. You'll see in a minute why. But I can plug in 0.501 and all these, and I can plug in those. So let's create a function that will help us determine all the slopes at once by simply plugging in. So I want to create the slope of PQ. The only point that is fixed is point P, right? So then I have here minus 0 and minus 0.5. y2 minus y1 over x2 minus x1. These two values do not ever change because I have to determine the slope between Q1 and P, the slope between Q2 and P, the slope between Q3 and P. So these will never change. This is the y2 and this is the x2. But then, what are the coordinates of Q? Can anyone dictate the coordinates of Q?
0.
The coordinates of Q are here. So this is the y and this is the x. So cosine pi x over x. So the function we create, cosine pi x, there is no need to write 0, divided by x minus 0.5. Let's put this in the graphing calculator. In y equals, let's create the function. Parentheses around the top, parentheses around the denominator. Since there is only one term at the top, you can get away without parentheses. However, I like to put parentheses everywhere I need to. Cosine pi x, close the parenthesis, close the parenthesis. In calculus, we will not be using degrees for angles. We will only be using radians. So make sure that you go to mode and make sure that your mode is in radians, not in degrees. So I'm going to do just that just now. So in mode, I see radian, I'm fine. So going back to y equals, divided by, in parentheses, x minus 0.5. And close the parentheses. So what am I trying to do? I'm trying to determine the slope of all those secant lines, step by step from left to right. So let's go to table right here. I have to, the software I think always goes back to the default. So I have to check whether in the table set, if I have the independent variable in ask mode. It has to be in ask mode. So scroll down and to the right. It's right here with second and table set, right here.
Second table.
Second and table set. The second one. You found it?
Yeah.
Perfect. Okay, so now let's go to second and table. Let me check. Did I press on enter? Yes, I did. Okay. Second and table set. So what is x? From left to right, I have it right here. 0, enter, 0.4, enter, 0.49, enter, 0.499, enter. Can I put in 0.5? What if I put in 0.5? What will happen? I'm going to get an error, of course, because the denominator is 0. The next in line is 0.501, 0.51, 0.6, and 1. So, yes, please. Yes, and you have perfect. So now you go to second and table set. That's perfect. Second and table now, and put in those values. 0.4. Is everyone with me? So what does this number represent? The slope of the line going from the first Q and P with Q with the x coordinate of 0. What is this? The slope of the line going through the second Q with x 0.4 and P. What is this? The third Q. What do you notice that happens here from left and right at the same time? X approaches, yes, here from approaches 0.5 with smaller values, and here X approaches 0.5 with larger values. And what do you think the actual slope of the tangent line at P would be? What if you say, I don't trust your 0.499 and I don't trust your 0.501? Okay, what will you do? Exactly, get closer. Excellent. So let's say with either 0.4999999, and let's see what happens, or with 0.5000001, and let's see what happens. So my guess would have been, if I hadn't gotten even closer, my guess would have been 3.142, right? But if we get even closer to that, look what happens. What is the exact slope of the tangent line at P? Negative 3.1. Could we have done this with algebra? No, we could have not done it with algebra, because I can determine the slope of a line with only 1 point. I need 2 points with algebra. I think we should look at another example. Any questions on this one? Any questions on this? Were you able to follow this example? Do you understand why I created the function? Only because I didn't want to punch it in for each and every one of them separately. Not because you have to create this function. Yes, Dylan?
Can I come clear my table?
By going to second and table set and being in the ask mode. So now you have nothing in your table. Is that okay?
Oh,
You have to have the independent variable in ask mode.
I thought it was closed.
We need another example. Is it a yes or a no?
Yes. Yes.
Yes? Okay, so let's choose another example. Let's look at problem 8. Now, if the function is a distance function, we're going to determine the instantaneous velocity. This one was the rate of change, the instantaneous rate of change, if you want, at P. So I didn't copy those numbers. Should I copy those numbers for you, or did you copy them? Do you have them, the slopes? Okay, here's what I would put in writing. So let's do that. So for different x values, the slope of PQ. So when x is 0, the slope of PQ is negative 2. When x is 0.4, the slope of PQ is negative 3.09. 0.49, the slope is negative 3.141. Notice that we were asked six decimal places. I did not copy all of them. I just copied the table. Is that okay with you, or you want me to go back and identify more digits? Would you be able to put in more digits if you need to, if you want to? Okay. decimal digit. Okay, so 0.49, and then 0.499. We got negative 3.142. The next one, 0.501, negative 3.142. The next in line was 0.51, negative 3.141. The next in line was 0.6, negative 3.09. And the last one was 1 with a slope of negative 2. 1, 2, 3, 4, 5, 6, 7, 8. And our conclusion was that the slope of the tangent at P was, after we created even closer point to P, from either side of P, what did we conclude? Negative 3.1. Now, in the next example that I would like to look at is problem 8. In this example, we are asked to determine the instantaneous velocity. Let's read it together. Any questions on this problem? So this is how you should present the information. Okay, for each and every point Q, we determined a different slope. And we were able to determine the tangent, the slope of the tangent line, analyzing from left and right the slopes of secant lines. Okay, so let's read problem 8 together. Here it is. The displacement, which is a distance function. The displacement in centimeters of a particle moving back and forth along a straight line is given by the equation. So we have the equation here, where t is measured in seconds. Find the average velocity. Same concept, the slope of the secant line. I'll explain in a minute. So find the average velocity during which time period, and we're given again points. Estimate the instantaneous velocity, which is the slope of the tangent line, to the graph of the function when the particle is at x equals 1. Ready? Okay. So this is problem 8. And after that, we can move on to the next section. So this is 8 this time on the same page, 86. So let's copy the information. We are given S, and it should be S of t, the displacement function or distance, 2 sine pi t plus 3 cosine pi t. Thank you. Okay, and we are given intervals, 1, 2. The next one is 1, 1.1. The next one is 1, 1.01. The next one is 1, 1.001, of course. 4 subintervals. Estimate, find the average velocity. I don't have to graph the function s of t, but I want to explain what's happening here. So of course this is our point P. And the coordinates, I did not plug in 1 radian just yet, but of course it's the coordinates of P will be 1, s of 1. So this is at 1, 2. So this is my Q1, 1, 1.1. Of course, it's forget about my unit. So this is my Q2. Of course, this is 1.0. What was that? 1.1? Yes, 1.101. Okay, so this is my Q3. And of course, 1.001 is my Q4. 1.001. So I have 2, I have 1.1, I have 1.01, and I have 1.001. So I'm asked to find the average velocity between P and Q1, then the average velocity between P and Q2, then the average velocity between P and Q3, and then the average velocity between P and Q4. What is the definition of the average velocity? Exactly, yes. The slope PQ1 is the average velocity between P and Q1. It's the exact same concept. It's as if this is a secant line, which it is for the displacement function. So MPQ1 will be y of Q1 minus y of P over x of Q1 minus x of P. And this is the average velocity. Average velocity between 1 and 2. I only have 4 slopes, 4 secant lines, 4 average velocities. Do I want to do them separately, or do I want to create a function and put the function in the calculator? It's up to you. Here there are only 4. Or we can create a function that we plug in.
I'd like to see how we make a function.
Perfect. Perfect. So then the average velocity, which is the point that does not change. Which of these two does not change? This point, which is Q1, or this point, which is P? Of course. Y of P will be 2 sine pi minus 3 cosine pi divided by 1. So this is the y for P, this one. I plugged in 1. And this is the x for P, which is 1.
This is like 2 sine pi?
Yes, because the function is 2 sine pi t plus 3 cosine pi t. So I replace t by 1 to get y of P. So now x of Q is x. What will be y of Q for any Q? The y coordinate. This whole thing, the function, exactly what we just did in the other problem. 2 sine pi x plus 3 cosine pi x. The y coordinate of Q minus the y coordinate of P over the x coordinate of Q minus the x coordinate of P. So this is the function. You don't have to calculate anything. You just have to make sure that you put parentheses around the numerator in the calculator and parentheses around the denominator. And we're going to get all 4 average velocities in a blink. But we have to put this function in. Do we all understand how we created the function? That's the most important thing. Do we understand how we created the function? Yes, please.
Can you go over that again?
Yes, yes. So for any Q, it could be Q1 or Q2 or Q3 or Q4, P is fixed. So this point Q has coordinates x comma s of x. I changed t into x, forgive me. You know what I mean. So then the next one will have x comma s of x, a different x. The next one will have x comma f of x, a different x. And x comma f of x, a different x. So I created the slope of the secant line. Y of Q minus y of P over x of Q minus x of P.
So the x coordinate is changing. For each
That's
Q.
why I left it as x, because I'm going to plug in 2, then I'm going to plug in 1.1, then I'm going to plug in 1.01, 101, and then 1.0001.
So for each y coordinate, it's not changing.
It will change, because when I plug in this expression 2, it's going to be a different number, and I plug in 2. Then when I plug in this expression 1.1, this will be 1.1, this will be 1.1. And it will create the second slope.
How did you get the right side?
This one?
Yeah.
This is S of 1. Because P is 1 comma S of 1. So this is the same function when X is 1 for P. That doesn't change.
Oh,
That's why this is a number. It's fixed. This is a number. It's fixed. This change, these two change. When X changes, the top changes because a different Y value. Then I move on to the next X, and this will change based on this X. So I create all 4 slopes or average velocities, putting this function in and getting all of them with the calculator. It's not wrong to do the same thing 4 times. So first you will here plug in 2, and then subtract that value, and then 2 minus 1. Then you will plug in 1.1, and then subtract that value over 1.1 minus 1. Or you create this function and put it in the calculator. Is this better? Yes? Okay, so let's put the function in y equals, clear what you had, and left parenthesis, 2 sine pi x, 2 sine in parentheses pi x, close the parenthesis, plus 3 cosine pi x, close the parenthesis, and close the parenthesis, no, not yet, I'm sorry, minus 2 sine pi, which we know, if you remember what is sine pi, sine pi is?
0.
Sine pi is 0, so I don't have to put it in. And cosine pi,
Negative.
-1 times -3, so it's plus 3. Or just put it in and close the parenthesis and divide by x minus 1. So one more time, -2 sine pi is 0, so that disappears. Cosine pi is -1 times -3 is positive 3. And now we're ready to go to second and table. And what do I plug in? What do I plug in?
The 1.1 values.
Yes, 2 first, because it's the furthest away. Then 1.1 will be the next. And then 1.01. And then 1.001. So the slope between Q1 and P, what is it?
6.
Or the average velocity between Q1 and P. What is the average velocity or the slope of the secant line between Q2 and P? What is the slope between Q3 and P? And the slope between Q4 and P. If you don't trust this, and I wouldn't, what would you do now? 1 point? Exactly. So, which the calculator couldn't even write, right? Because it's so close to 1. But if I plug in 1, right? So what is the slope or the instantaneous velocity or the slope of the tangent line at P? Yeah, if you want to see it with more decimal digits, then you're going to highlight it, and it gives us -6.2832. Now I'm going to write all the information. Yes, please.
Why is there a y value for one of the ones and then error for another one?
Because I put one in to show that we can put 1 in. Just to emphasize that a few minutes I said that age approaches 0, not equal to 0.
Yeah.
Same thing here. X approaches 1, but not ever equals 1.
Oh,
So
it was like
this
a
one,
it was like
the one on the
1.60.
left is not 1. The one on the left is 1.0000. But this one that I plugged in
It's just 1.
is just 1.
Okay.
So for just 1, I will always get an error. Yes, please. Oh, the function, yes. So I'm going to copy now the table. So you have it. Ready? So x average velocity PQ. Oh, ready? Sorry about that. So here's my table. Come on, come on, come on, come on, come on. Okay. So x average velocity PQ. So when x is 2, we got 6. Measurement unit. We're going to talk about the measurement unit in a minute. When x was 1.1, we got negative 4.712. It doesn't mean a negative speed. It just means that the particle is coming back. When we plug in 1.01, the average velocity was negative 6.134. When we plugged in 1.001, the average velocity was negative 6.268. And then we concluded that the instantaneous velocity at P is, what did we say?
Negative 6.283.
Very good. Is negative 6.2832, I think, when we looked at it. Just looking at the table one more time. Yes, 2832. Measurement units. We can't draw any conclusion or finish the problem without deciding what is the measurement unit. So it was in centimeters, and the distance was measured in centimeters, and the time is measured in seconds. So I need the measurement unit for all these, including for the instantaneous velocity. Measurement unit.
Second.
So remember the slope and the average velocity. They have two measurement units. One coming from the top and one coming from the bottom. Is the average rate of change of the distance with respect to time. So the distance has a measurement unit. Time has a different measurement unit. If you call me, I'm driving, and you call me on my cell phone, and I say, hey, how are you doing? And you ask me, what is your speed at the moment? I would not say 60 miles. I would say
60 miles per hour.
60 miles per hour. So any rate of change has two measurement units, one coming from the top and one coming from the bottom, because it's a ratio. So what is the measurement unit then?
Seconds per.
Yes, centimeters per second. All of them. The 6, the negative 4.712, all of them have centimeters per second. Any questions? Yes, please. 2 questions. This one? I plug in the calculator 1.00000000001. Got it? So when you plug in 1.0000001,
Do you just
have to look at
What?
the-
Do you just do a whole homework thing? Because like if we can, obviously homework is optional.
Yeah.
So she gets
I'm
full
not sure
this
why.
science.
Is it tolerance of the calculator? Maybe my software is different. Did anyone else get a different number than negative 6.2832?
Yeah.
Yeah, so I guess this is the computer software that I'm using. I'm not using the calculator, so it may be a tiny error. I'm sorry about that. I didn't realize that it was slightly different. Yes, you had a question.
So the answer saying the instantaneous velocity at p is the same thing as saying the slope of the tangent line.
Exactly. Let's write that down. Is it because that was my next step. So the slope of the tangent line to the graph of a function. The slope of the tangent line to the graph of a function is calculated in the same way as the instantaneous rate of change of that function, of the function with respect to, yes, same concept, identical. For homework, I would like you to work on problems, just 2 problems, and turn them in step by step. They are odd number problems. They have the answer in the back. However, I'm interested in your work and how you determine each and every step and show it to me. Okay? So there are 3 and 5. Yes? Dylan?
You're saying homework is probably for the book.
So 3 and 5. Yeah, so you find it in the ebook in the Web Assigned. So the ebook is the same with the book on page 86. So problems 3 and 5 on page 86. And they are due on Tuesday. Any questions for me? Yes, please.
If we have a hard copy of the textbook, do we still have to submit them online?
You don't have to submit anything online if you don't want to. So you would prefer submitting the Web Assign online instead